Hi, and welcome to the training video for the P266 programming tool. The part number for this new software is P266PRM-1K. The software is used to simplify the programming of the P266 single-phase fan speed control. It can be loaded onto any Microsoft Windows-based PC. This video will help familiarize yourself with this new programming tool, allowing you to easily configure and program the P266 control. Before we get into the programming with this new tool, there are several documents which should be reviewed to help familiarize yourself with the tool as well as the P266 control itself. The P266 utility manual for this software is LIT-12011741. The installation and wiring instructions for the P266 single-stage condenser fan speed control is 24-7664-2705. These documents can all be found on our Johnson Controls Quick Lit website. Now let's familiarize ourselves with the programming tool. The software loads like any Windows-based software, and for the purpose of this training, it will be assumed that the P266 programming tool is already installed on your computer. Simply double-click on the on-screen icon. The menu choices are along the top row of the toolbar. File gives us four options: New, Open, Save, and Save As. New is for when you want to create a brand new file, which we will do in a little while. Open is for when you'd like to retrieve a previously configured file. Use this option if you are programming more than one P266 fan speed control and you want the same parameters loaded into each device. This would be ideal for the OEM who needs to program multiple units on the assembly line. The Save and Save As are used to save the unique configuration you just created in a file name of your own choosing. COM port identifies which USB port is used on the computer to communicate with the P266 control. Usually you want to use the highest COM port number. The best way to identify if the software is communicating with the control is to press the Read P266 button. We will cover this shortly. The sensor configuration allows us to choose one of two sensors which are pre-configured with the P266 control. The P266 SNR-1C has a range of 0 to 508 psi. The P266 SNR-2C has a range of 0 to 754 psi. These sensors provide a voltage signal that is proportional to the pressure that they are sensing. It is important to select the correct sensor type to match the sensor that is connected to the P266 control. You'll also notice that there is a custom choice. This will allow us to choose a sensor that is not pre-configured with the control. In the dip switch menu, there's a single item titled Dip Switch Viewer. The purpose of this feature is instructional. Using the dip switch viewer does not change any settings within a P266 control, but it shows you how information is entered via the dip switches when a P266 control is programmed manually. The help identifies which version of software the P266 programming tool is currently using. Let's connect the P266 to the computer. First, plug the cable into the three-prong plug located just to the right of the blue button. Make sure the red dot is pointing up towards the dip switches. Then, plug the other end of the cable into a USB port on your computer. Apply power to the P266 control. To see if the control is communicating with the software, press the Read P266 button. If you get a message, "Cannot read data from the P266, try selecting a higher COM port. Usually the highest one works best. Press the Read P266 button again. You can see that we were successfully read, so you know the computer is not communicating with the control. Now we are ready to begin programming with the P266 control. Select File, select New. You notice how it zeroes out all the data on the screen. Next we have to choose which sensor we're going to use. I like to use the P266 SNR-1C, and I'm going to work in PSI, even though I could choose to work in bar. The start and end pressures, SP and EP, on the programming tool can be adjusted using either the mouse or by using the up and down buttons on your computer keyboard. The start and end pressures are refrigerant dependent and may also depend on the geographical location of where the equipment is installed. You can determine the start and end pressures from the refrigerant pressure temperature charts, or PT charts for short. Each refrigerant has its own unique PT chart. These can easily be found on the web or provided by your refrigerant supplier. For our purposes, let's use R404A in a Midwestern climate. The start pressure should be about 220 psi. Now you'll notice I can't quite get there, so we're going to leave it at 221. The end pressure should be about 55 psi higher, or right around 275. Again, looks like I can't get there, so we're going to leave it at 276. Next, select the type of compressor which is being used on the system. If the system is using a digital scroll compressor, you need to select scroll for the type of compressor, or the condenser fans may oscillate. You will also need to select the frequency cycle for the compressor. Digital scroll compressors cycle on and off when in operation, usually in intervals up to 4 times per minute. During this cycle, the compressor achieves a high pressure point. The purpose of the selection range is to set an interval which will allow the compressor to reach the maximum pressure. If the interval is too short, this may cause the condenser fans to oscillate. Digital scroll compressor manufacturers usually identify this interval, and it would be recommended to use this interval and maybe just a little bit more on the time range, as no harm will be done if the interval is longer. So I'm going to select 20 seconds. Next, we select the start voltage. The start voltage is the voltage delivered by the P266 control to the fan motor to run the motor at the minimum speed in your application. The start voltage value is a percentage of the P266 control's input voltage. The factory default for the start voltage is 40%, and it's usually adequate for most applications. The end voltage is the voltage output by the P266 control as a percentage of the full voltage that is maintained when the monitored pressure is equal to or greater than the end pressure. The end voltage mode can be set to either 95% or 97% of the total input voltage. I'm going to keep it at 95%. Next, you can check the boxes of the split winding mode for the M2 triac and the LSC, which stands for low speed capacitor, for the M3 triac. Now, it must be noted that not every P266 fan speed control has the necessary triacs for split winding mode and the low speed capacitor mode. In fact, the majority of the controls that we currently sell are of the single triac variety. These models include the P266 ACA-100C, ACA-500C, BCA-100C, BCA-500C, BDA-100C, ECA-100C, EDA-100C, EDA-1K, EEA-100C, and the EFA-100C. All other models will have either 2 triacs or 3 triacs, so the following discussion on the split winding mode and low speed capacitor mode would be appropriate. Some single-phase PSC motors have split winding motor wire leads. Setting the split winding mode on enables the M2 triac to provide voltage to the main windings and not the auxiliary windings, which improves motor efficiencies. In some fan speed applications, a user-supplied low-speed capacitor can be connected to the P266 series control M3 triac and the controlled fan motor. A low-speed capacitor is enabled at low voltages to enhance the fan motor efficiency and performance. Refer to the installation manual of the P266 control for more information on these 2 features. The changeover voltage value determines the voltage at which the P266 series control enables and disables the M3 triac and the low-speed capacitor, or LSC. This is only used if the P266 control is wired in this configuration. You can determine the changeover voltage value by following the instructions within the P266 installation manual. Practical experience indicates that the factory default of 60% is fine for most applications. Lastly, you can select the number of auxiliary fans that are used in the application. You can set the P266 series control to cycle on and off up to 3 additional fixed speed fans, or in the case of a variable speed fan, you can control 3 speeds on that variable speed fan. 3 low voltage circuits can be wired to auxiliary fan starters or the stage starters in the case of a variable speed fan. If you are using auxiliary fans in your application, you will also need to set the overlap value for the application. The auxiliary fan overlap value determines the pressure range overlap as a percentage of the total pressure range between the fan stages as controlled by the P266 control. The fan overlap value is equal for all auxiliary fan stages set up on the control. If you increase the overlap value, it will decrease the on and off cycling rate of the auxiliary fans. This also increases the pressure differential between the auxiliary fan stages. Practical experience suggests that this setting should be in the 30 to 40% range. I'm going to select 35%. Please note that if the P266 series control is set for no auxiliary fans, the auxiliary fan overlap value is not used. Now you are ready to load the program to the P266 control. Press the load button. You should get a message that the setup data was successfully loaded. Now we can save our program. Select a name that is familiar with the location of where the P266 is installed. I'm going to select JCI, Building 7, Floor 3, and it's going to be used on the air handling unit number 1. Press save, and I can see that it's been successfully saved. I can now use this program to load the same parameters to other P266 controls. For additional information on the programming with this new utility program or other information on the P266 single speed condenser fan control, please refer to the documents mentioned at the beginning of this video. Thank you.